An electron of mass charge falls through a distance h in a uniform electric field. Uniform electric field charge means acceleration equal to q e by m. So in place of q we can write e. And then time of fall. Height is h, time of fall. So the charged particle should travel a displacement equal to h under this acceleration. Then time. Displacement time means s equal to ut plus half at square, isn't it? Initial velocity 0. Now this in this expression and solve for t. Hope you understood. Acceleration we found out. Displacement is h. They are asking time. So st means s equal to ut plus half at square. Substitute this in this. S is h. Half. Acceleration is e by m into t square. Time is 2mh. Time is 2mh under root. And then this. See? Under root 2hm. This should be the answer. Divided by E into E. So this is how you should use combination of equations or two formula. If this and this represents electric field at a point on the axial to equatorial of a dipole. So this is a dipole plus minus. This is electric field at a point on the axis, which is constant 2p by r cube. At a point on the equatorial plane, constant minus p by r cube. This is one time, this is two times. Therefore, this should be electric field at a point on the axis should be minus 2 times electric field at a point on the equatorial, minus 2e. So if you know equations, you can readily relate and get the answer. So what is the idea? Moral of the story? Make sure that you know all the equations that are there in your syllabus. If you are thorough with equations, it is easy to pick, rearrange and get equations or get answers for such questions. And students, if you are not thorough with equations and you yourself know that you are not thorough, then you will not have confidence to attend questions. Two spheres of electric charges are placed at a distance d apart. If they are allowed to touch each other, what's the new distance between them to get a repulsive force of same magnitude? So force is proportional to product of the charges by distance square. Fine. Initially 2 and minus 8 nano, don't worry about nano. 2 and minus 8. Then this force is proportional to product 8 into 2 by distance square. Okay. Now they are allowed to touch. Resultant is 2 minus 8 is minus 6. They are separated. Minus 6 becomes minus 3 and minus 3. Now force after. So force after is proportional to product of the charges 3 into 3 by new distance square. Here force before contact is equal to force after contact. That's the condition. And we have to find the distance where force before is equal to force after. Means this equal to this. 8 into 2, 8 into 2 by d square is equal to 3 into 3 by d dash square. We have to find this distance after. Observe numbers carefully. There is square. So take square root. 8 into 2, 16. Square root is 4 by d. This is 3 by d dash. So d dash is 3 by 4 times d. This is equals, okay, 3 by 4 d. Electrons are removed from a neutral metal sphere of diameter 20 centimeter. Sphere radius is 10 centimeter. The magnitude of the electric field at a distance 20 centimeter. So this is point P at a distance 20 centimeter from the center is. So electric field at a point outside the charged sphere means electric field is constant charge by r square outside the sphere. But this charge is n into e. Quantization of charge, isn't it? Good, because number of electrons are mentioned. So electric field constant 9 10 to the power of 9. Number of electrons 10 to the 4 10 to the power of 10. Charge of electron 1.6 minus 19. Don't worry about negative sign. Since electron is negatively charged, forget. By distance square. Distance is 20 centimeter. 2 10 to the power of minus 1 square. Hope you understood this. 20 is 2 10 to the power of 1. Centi is 10 to the power of minus 2. So 2 10 to the power of minus 1. 2 10 to the power of minus 1. It's square. Now manage the numbers. Look at those. They are quite distinct values. 2 square 4 get cancels. 1.6 into 9 144 point 144 is here. Stop further simplification because 144 is found only in that fourth option. If you simplify fully, then also you'll get 1440. Okay, good. So we are using quantization of charge in place of Q, n into E, and then electric field at a point outside the sphere. Diameter is given, diameter to radius. Radius is 10 centimeter. Point is at a distance 20 centimeter means the point is outside the sphere. So that's why this expression. Three point charges are placed at the corners of an equilateral triangle of side x. The magnitude of the electric dipole moment of this system is, this is an equilateral triangle. 2q, 2q minus 4q. 2q, 2q minus 4q. Length of each side is x. 2q, 2q, positive charge center is at the center. So this and this, these two are imagined to be concentrated here. So it is 4q. See, this charge and this minus 4q, equal and opposite charges separated by this distance. Separated by this distance. Look at the options. If it is this distance, it should be this. Root 3 is involved. You will understand why. See, triangle. Dipole moment is charge into distance between the charges. Charge is 4q. Charge is 4q. 4q. 2a is distance between the charges. In this case, it is this distance. This total distance is x. Half of the distance is x by 2. This is x. Other side. Carefully observe. X by 2 into 2. 2 get cancels. We get x. So this distance is 2 times x by 2. This length is 1 time x by 2. Therefore, I want this. Common factor is x by 2. Remaining is 2. If you take out x by 2, remaining is 2. 2 square is 4. 1 square is 1. 4 minus 1, 3 under root. So this length is x by 2 root 3. X by 2 root 3. See? Magnitude of charge is 4q. Distance is this. Root 3 is there in the numerator. So whenever we find that this length is involved, there should be a root 3 term. That's why this is the answer. If you simplify this, 2 1 time, 2 2 times, 2 root 3. 2 root 3 qx. 2 root 3 qx. The magnitude of point charge due to which electric field 30 centimeter away from the magnitude. Direct question, isn't it? Electric field equal to constant q by r square. Electric field is 2. Constant 9 10 to the power of 9. Charge wanted by distance square. 30 centimeter is 3 10 to the power of minus 1 square. Try to write 30 centimeter as 3 10 to the power of 1 centi minus 2. So it is 3 10 to the power of minus 1. Okay. See, square 3. This get cancels with this. So q is with 2 with some 10 power. 2. The force of repulsion between two identical positive charges when kept with a separation of r in area is F. Fine. Half the gap between the two charges is filled by a dielectric slab of constant 4. Then the new force of repulsion between those two charges become. So these two are the charges Q1, Q2. Distance is R, force is F, and F equal to constant product of the charges Q1, Q2 by R square. No issues, right? Now, these two charges, same two charges separated by same distance. Half of the gap is filled with dielectric constant 4. So this is half of the gap. So this gap is filled with dielectric constant. These two are the charges Q1, Q2. Now if Q1, Q2 are the charges, half of the means let this thickness be d by 2. The remaining is also d by 2. So dielectric constant of air is 1. Dielectric constant of this medium is 4. It is mentioned. And new force is given by constant product of the charges Q1, Q2 by, there is a dielectric medium, root of dielectric constant into d by 2, because half of this is filled with half d by 2. Half of is filled with 4 plus remaining half d by 2 is filled with air square. So this is how you should solve this problem. Constant Q1, Q2 by, let me take d common factor, and outside this bracket means it becomes d square. Remaining is this 4 here, it becomes root 4, 2, 2 by 2, 1, 1 plus 1 by 2, 1 by 2, 1 by 2, and its square equals, this whole thing is force in air, isn't it? So force in air divided by 1 plus 1 by 2 is 3 by 2 square. So this is 4 by 9 times F. 4 by 9 times F. This is modified form if distance between or gap between the charges is partially filled. So in this case, half, the other half. Half is filled with dielectric constant, the other half is with air. So this is 4F by 9. A certain charge Q2Q is divided at first into two parts, Q1 and Q2. Later, the charges are placed at a certain distance. If the force of interaction between the two charges is maximum, then Q by Q1 is 1. Why it is 1? Forget 2Q, okay? Forget 2Q. If there is a charge Q, and if this is split into 2, half and half, then force is maximum. Force is maximum if this charge is equally divided into 2. Suppose if this charge is divided like this, 1/4 and remaining is 3/4. What's the magnitude of the product of these two? Because force is proportional to Q1 into Q2, isn't it? If product of two charges is maximum, then force is maximum. Half into half is 1 by 4. 1 by 4 is 0.25. Now, if it is divided like this, 1/4 and 3/4. What is 1/4? 1/4. What is 3/4? 0.75. Say 0.75 by 4 is 0.1. This is 7. This is 4. 1 something. If you split the charge equally, then force is maximum. If you split unequally, then force is less than the maximum. Now, there is 2Q. Half of 2Q is Q. What is the remaining? That is also Q. So, this is the total charge. Q1 is Q. Q2 is Q. Q1 equal to Q. Q2 equal to Q. Now, what is the ratio of Q to Q1? This to this is 1. That is the meaning of the problem. So, as soon as we find maximum and this ratio, it should be 1. An electric dipole is kept in uniform electric field. It generally experiences non-uniform electric field. Let this be non-uniform electric field. Lines are crowded means stronger field, less crowded, weaker field. If there is a dipole like this, minus Q and this is plus Q. Plus Q experiences force in the direction of the field, whereas this experiences against the direction of the field. Hope you understood. This charge, negative charge, is in a stronger field. Therefore, magnitude of force is greater than this force. Unequal forces means there is resultant force. So, resultant force Fr is not equal to 0. Since these two are not acting on the same line, there is torque. Even torque is not equal to 0. Means there is resultant force, there is resultant torque. If it is non-uniform, then it is force and torque. Both are present. In our syllabus, electric dipole is in uniform electric field. Uniform electric field means there is only torque, there is no resultant force, and this is non-uniform. An infinitely long, thin, straight wire, uniform charge density. What is the magnitude of electric field at a distance 20 centimeter? So electric field due to line of charge. This is line of charge. Electric field at any point is given by constant 2 lambda by r. Constant is 9 10 to the power of 9. 2 lambda is 1 by 4 10 to the power of minus 2 by distance 20 centimeter 2 10 to the power of minus 1. 2 to 9 by 4. 9 by 4 is 9 by 2 is 4.5. Another half is 2.25. 10 to the power of, don't worry, 2.25 is here. 2 gone, 9 by 4, 2.25.